All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be continuing learning about LeRoBot. More specifically, I think today we are mainly going to be focusing on LeRoBot dataset class, which is a class that you use to load datasets and also work with the datasets. Give me a second here while I open up my chat on my phone. Also, yesterday, wait, hold on. Let me just load this up and we are good to go. Okay, yesterday, I ran into a bit of an issue, right? I think it was on stream. I believe it was, yeah, it was on stream. It was on stream, and on stream, I'd found out that, yeah, this is like a Python version issue. Oh, give me a second. Okay, I suddenly put a, a load on my system. So I need to handle that real quick. Let me just unload a bunch of things so that the stream doesn't crash. Okay, that is fine. This is apparently not fine. So let's reopen this and then, okay, yeah, let's unload that as well, just until the connection stabilizes. Okay, open this up, open that up, and I think we are good to go. Let me also just pause this video feed. Okay, yeah, hopefully we are good. So yesterday, at the end, towards the end of yesterday's stream, we had found out that the reason we were getting this weird error when trying to use. Hold on, I just closed it. I need to open it up again. Anyways, okay, we'll get to that. But when we were trying to load a dataset using LeRoBot dataset, we were getting an error that had something to do with pickler something something, right? And I fed that entire error into Gemini, and Gemini mentioned that Gemini explained that okay, the reason for this is because in between um, Python, in between the older version of Python and newer version of Python, there was some changes that are causing this issue. So you are not supposed to be using Python 3.14 with LeRoBot. You generally want to use something like 3.10 or 3.11. And then I went and looked at the installation instructions on the LeRoBot documentation side, and even there they mention 3.10. They didn't mention any later versions. Okay, great. So I tried to install through I installed I installed Python 3.10, and then I created the environment, and then I tried to install LeRoBot. I went for the old I went with the old method that I was using, where I would install the CPU version of PyTorch first and then try to install um, LeRoBot. But the problem was that it was starting to it was still using not using, it was still trying to install PyTorch CUDA, despite me having PyTorch CPU installed. It was still trying to install PyTorch CUDA. So then I asked Gemini for, you know, um, give me a second. Yeah, then I asked Gemini for advice on this, and through that I found out that we need to be using this extra flag. The flag is extra index URL. Actually, even before this, um, well, yeah, okay. So I found out I had to use this extra index URL thing. Um, then, after I managed to install LeRoBot and have LeRoBot install the CPU version of PyTorch, which is great because now that I'm specifying um, this thing, extra index URL, for PyTorch. Now that I'm specifying extra index URL, I don't need to install PyTorch first. And where was I going with this? Yeah. So I then installed the I then installed LeRoBot along with PyTorch, and it wasn't installing. It wasn't trying to install PyTorch CUDA anymore, which was great. Then I opened it up and I tried going with that same. I tried using that same code that I was using before, but this time I was getting like API related errors. It was saying that the LeRoBot dataset module was not found. And then I went and checked. Apparently, it was installing an older version. I think it was because I was installing it on Python 3.10. So when I tried to install LeRoBot from PyPy, it was installing an older version of LeRoBot. It was 0.1.0, I think. And the latest version is somewhere zero point 0.4 point something. And in between these two versions, they've had a couple of changes. One of those changes had to do with where LeRoBot dataset was located. So the namespace kind of changed, and so that's why the code that I was using wouldn't have worked with the older version of LeRoBot. Now the solution wasn't to change the code. The solution was to make sure that LeRoBot, latest version is getting installed. And one solution for that was this installing directly from the LeRoBot repo. And another solution would have been, hold on, I did it somewhere here. Yeah, this. Another solution would have been to just specify LeRoBot in this way. So you do LeRoBot and then you specify a version greater than or equal to 0.4.0. So then it's going to fetch that specific version off of PyPy, and it's going to install that. And then because you're using this extra index URL thing, so it's also going to install PyTorch CPU version. And then I ran into one last issue that I had to solve. After all this, after this installation is done, actually the installation doesn't complete here. There's something called setup tools that runs, and in either PyTorch or in LeRoBot, there's an older version of setup tools, whereas LeRoBot needs a higher version of setup tools, a more later version of setup tools. So what UV pip install was doing is it was trying to use the older version of setup tools, which it found. I believe that's what it found. Yeah, it says hint setup tools was found on so and so, which is the PyTorch link that I had given, but not at the requested version, which is this. So it requires so and so version, right? A compatible version may be available on a subsequent index. By default, UV will only consider versions that are published on the first index that contains a given package to avoid dependency confusion attacks. If all indexes are equally trusted, then use so and so flag. That is this flag. Let me highlight the thing. Yeah, use this flag. Index strategy, unsafe best match to consider all versions from all indexes, regardless of the order in which they are defined. So I added that, and after that, as you can see here with the output, the entire thing installed perfectly fine. Great, awesome. Then I ran the code, and then there was one last error. I know I previously said that that was the last error. There was one last error that showed up here, the final error that I had to deal with, and I'm glad that they actually put instructions here. I haven't fully paid attention to what exactly is happening, but at least from what I understand, it's that it's downloading and converting, or it's downloading directly a new version, a newer format of the data set that we are trying to load, because the version that was being downloaded, for whatever reason, it was the older version, and that's mentioned here. The data set you requested, LeRoBot so and so, is in 2.5, is in 2.1 format. We introduced a new format since version 3.0, which is not backward compatible with version 2.1 with version 2.1. I'm assuming the 2.1 and 3.3.0 thing, this is to do with LeRoBot dataset. This is a version of LeRoBot dataset because that's the format, right? Actually, okay, this is a version of LeRoBot dataset format. That's more accurate to say. And well, they provided this neat little command that you can run to in order to get the latest version. Okay, hold on. Yeah, so I haven't paid attention to what exactly this line is doing. Is it first, is it only converting the data set to a new format, or is it first downloading? Because in my case, it first downloaded. So I don't know if it's going to check if you have like a cached version, or is it going to download a new version regardless, and then caching maybe. I don't know if there's caching involved at all. But yeah, it does. In my case, uh, it downloaded the version, and I think after downloading, either it converted or what it downloaded was the new version to begin with. One of these two. I'm gonna have to look into. I'm gonna have to look into what exactly this tool is. You know what? Okay, I can ask this question to Gemini. Give me a second here. Just gonna do some stuff that speeds things up a tiny bit. And we are going to get right into using LeRoBot dataset. After that, I mean, after I've done that, then we'll get into using LeRoBot dataset. Man, yesterday I was supposed to continue my Rust basics studies after yesterday's stream, but then I kind of got busy with trying to solve this issue, and I'm glad that I took the time to solve it because, well, I solved the issue, and now we can actually continue learning about LeRoBot. But yeah, today I should probably continue with that studies because I want to finish learning the basics before I move on to more heavier stuff. I still haven't finished learning about Tokyo. Fortunately, I have that Gemini course that I'd set up for learning Tokyo, and fortunately, I will also be, or hopefully, I'll also be able to continue that. I think I should be able to continue it because this is one thing that I realized about Gemini CLI specifically, is that so you have the concept of checkpoints, right? Where you can save checkpoints within a certain directory, and then you can jump back to that conversation and that specific point in the conversation as long as you're within that directory. I found certain issues with persistence when it came to those checkpoints because certain checkpoints just seem to vanish. I'm not really sure what happened with them. Did I run out of memory or did it expire? Is there an expiry date? I don't know what the situation was, but at one point I was trying to, find the different. Actually, I can show it here if I just look at one of my Gemini conversations. Um, this one is gonna have to load up. Well, this is the empty directory thing, right? Real quick, let me just make sure that I'm comfortable with showing everything. Hey, I do Python coding. Okay. I want to learn about transformers. I have an MP4 file. Develop and deploy HF spaces via terminal workflow. Okay, I have a couple of old Android devices. I've been looking into learning Fun DSP. I've been learning about sine waves. I'm learning Lua. I need to continue with that, by the way. Holy shit, I forgot about that. I do need to continue with that. And my way of learning Lua is going to be, well, I've learned Lua at this point. Um, I've learned like the basics. That's the amazing thing about this language. It's a really simple language, but it still provides you with like a very, it provides you with the capability to do very sophisticated things because this language is meant to be an embedded language. Now, hold on, let me finish. going through this list, so I'm sure that I'm comfortable with showing everything. I'm considering using Rust to build a sort of web app. Okay. I'm learning about protobuf. Um, in Python, when you create a meta class, okay, Rust-based SSG. Okay. All right. Great. Yeah, I'm okay with showing this. So this is what it looks like. Let me hit escape so I can do the resume thing again. So you just do resume when you're in a certain directory, and then it shows you auto-saved versions of various conversations that you've had. I haven't even saved these. These are like just auto-saved. And you can see like the age of the conversation, how far back the conversation was. I don't know if it's when the conversation started. I think it's when the conversation started. I think so. Because all of these are like the starting portions of the conversation, not the ending portion of the conversation. So yeah, through this, I'm able to just like resume any previous conversations that I've had. I think this is also how I saved one or two of my other Rust. Yeah, I think that's how I saved my Rust. Saved from getting lost, because I was not able to find the checkpoint, and I was like, holy shit, is the conversation just gone completely? And then thanks to this resume thing, I was able to get back to it, and yeah, I'm happy about that. Okay. Yeah, I was supposed to do this. Hey, so um I'm doing well, I'm learning LeRoBot. I was recommended to use this line. Um, Let me paste it. Wait, is there like a, hold on. Okay, yeah. Um, this line, um, in order to be able to download and use one of the data sets, can you explain to me exactly what this line does? I can also paste the entire error where this line was suggested by the library if you need. It sounds like you're diving into the LeRoBot ecosystem. It's a fantastic library for robot learning, but like many fast-moving projects, it occasionally has breaking version changes. That specific command is a data migration utility. Here's a breakdown of what is happening under the hood. The breakdown: Python M. This tells Python to run a specific module as a script, and then we have lerobot.datasets.v30. I think that's version 3.0. Okay, dot convert underscore data. Why am I reading the entire thing? Yeah, whatever. The entire name. That's right there. This is a path to a conversion script within the LeRoBot library. It's designed to transform an older dataset format, version 2.1, into the newer format, version 3.0. Then repo ID. This points to the specific dataset on the Hugging Face hub that you want to download and convert. Okay. Why do you need this? The LeRoBot. Okay, so it's downloading and then converting. Okay, all right. The LeRoBot library recently updated how it stores data, moving to version 3.0. The newer version uses Apache Rechunk and a different folder structure to make training faster and more efficient. If you try to load an older dataset, version 2.1, using the latest version of the code, it'll fail because the code expects the new structure. The library is being helpful by sensing the old format and giving you the exact command to fix it locally. What happens when you run it? Download. It pulls the original version 2.1 files from The Hugging Face Hub. I need to, hold on, I need to go take a look at this specific, wait, I can look at it here, right? Um, I have Hugging Face open here. We can search for data sets, so I can just directly type the entire thing in here. So let me open up a new tab and we can search for this and see if there's any like format related information that pops up. In the meantime, while this is loading, I can continue reading. So it first downloads, it pulls the original version 2.1 files from the Hugging Face Hub, then transformation. It reprocesses the images, joint states, and episodes into a new format, into the new format, which is, I'm assuming, version 3.0, and then local storage. It saves the converted. Okay, so that's the caching part. It saves the converted version to your local cache, which is usually .cache slash hugging face slash LeRoBot. A quick tip, if you are seeing an error like value error, dataset format so and so is not supported, running this command should resolve it immediately. However, ensure you have enough disk space as the conversion process essentially creates a second updated copy of the data on your machine. I need to keep that in mind because I have had situations where the cache filled up. Let me just check. Hold on. Let me open up Yahtzee. I can open up Yahtzee here. Actually, I don't want to play too much with this because I have to make a social media post about this because this information, I feel like it can help other people who might currently be using LeRoBot because LeRoBot is actively being developed and the community is actively, expanding. So I feel like this bit of information, putting it out on social media is probably going to help people. Man, I need to, holy shit. I really wish I would have taken the time to work on that automated tool for my knowledge base, for my website, in fact. Like I didn't take the time to finish learning Zola, and so I didn't finish learning how to create websites using Zola, and because of that, I also didn't work on a automation tool to handle parsing the entire what do you call it? The entire knowledge base that I have, which is in JSON format, to something that Zola can use. Something I need to look into is a way to index all of that because this is something that I've learned. Whenever you wanna work on some kind of search functionality, some kind of search utility, there is a certain level of indexing involved. It has to like crawl through the entire thing, whatever the entire structure is. It has to crawl through that entire structure and index all of the relevant data. So the relevant data can be, file names or page names or whatever data is within the page. It has to do certain level of indexing before you can use it as a search utility. I believe that indexing is what builds a database for the search utility to use. And fortunately, Zola does provide that kind of a thing. I need to see if I'm able to customize it and have multiple such search utilities. So then I can have one search utility for my knowledge base, and I can have another search utility for what? I can have another search utility for my Gemini conversations that I'm exporting. So I'm going to need to write a couple of tools here in order to, dude, I should sit down and write down these ideas. But before that, let me, okay, website. Um, I don't want to say website design, website software design, website architecture design. Um, so we're gonna need Gemini Convo conversion tool. I guess we can add spaces. This doesn't need to be like a name kind of thing. Knowledge base conversion tool. Um, oh, I could do it in this way. Hold on. Conversion tool and search utility. Gemini Convo. And then here we can do conversion tool and also search utility. So then I can get rid of this. Okay, so these are two things that I basically have the content for these things. Actually, I need to find a proper way to organize this content as well. Because the Gemini conversations are basically very long markdown files, which are just going to be, rendered as oh, hold up. I didn't think about this. How is the markdown going to be rendered exactly? I might need to use, what was it called? Was it called Pandoc? Hold on. There was a tool that I'd used that had to do with pandas. Pandoc. If you need to convert files from one markup format to another, Pandoc is your Swiss Army knife. This is the one. Pandoc. I think I need to use Pandoc to create the HTML file. So it converts the markdown into HTML, so you can then render it, because browsers by default, they don't just render markdown files. You do need some sort of renderer for it, or you have to convert it. Let me just open up a conversation with Gemini and check. Dude, I'm so glad that I'm using Gemini to do these various things, do all of my research and handle various like errors and stuff. Dude, the the amount of time that Gemini has saved me with this LeRoBot thing alone, like this would have taken me days to solve a whole bunch of like Googling and seeing other people running into the issue, and then maybe I would have had to, uh, type out some kind of forum post and then wait for somebody's response and stuff like that. Instead of that, I just had a conversation with Gemini. I copy pasted the entire error as is, and Gemini just explained the entire thing and also mentioned, hey, this is the problem, this is the solution. And if I had very specific things that I wanted to do, that I wanted to customize within that solution, Gemini would also give me ways to customize that. So, like, holy shit, Gemini has saved me so much time. It is insane. Okay, I have a markdown file. In the past, you have suggested using Pandoc to convert this file to HTML so that it can be rendered. This has me wondering, do browsers not support uh, markdown rendering by default? Kind of like how you can render MD in GitHub. It's a common point of confusion, especially since Markdown is so ubiquitous today. The short answer is no. Web browsers do not support Markdown rendering by default. When you open a Markdown file in a browser like Chrome or like Chrome, Firefox, or Safari, it treats it as plain text. It displays the raw hashes, asterisks, and brackets exactly as they are written. Here's a breakdown of why this is the case and how GitHub makes it look so seamless. Why don't browsers just support it? Web browsers are designed to interpret HTML. HTML is the native language of the web, and its specifications are strictly managed by organizations like the W3C. No single standard. This was, hold on, Markdown. There was a specific, I remember, I think it was in Zola or in whatever templating engine Zola is using. I forgot the name of that. It's not Jinja. Jinja is for the Python SSG, which I forgot what. Yeah, Jinja is for Pelican. What does Zola use? I forgot. It had a unique name. Hold on, let me Zola SSG. Zola SSG template, because there's a templating engine. Terra. Terra is the templating engine. Why was I talking about Terra? Yeah, I think it was either mentioned in Zola or in Terra. The thing about Markdown, because like they are using a version of Markdown that is actually being worked on by an active community. And these people are aiming to turn this into a proper Markdown standard. I remember that there was a website, there was a web page where I had read up on this whole thing about the new Markdown. Let me also see. Okay, Zola SSG Markdown. It had a specific name, Common Mark. There you go. That's what it's called, Common Mark, which is a strongly defined specification of Markdown. So if you look up Common Mark on Google, you'll probably find, well, I mean, look up Common Mark Markdown just to, make sure it's giving you the Markdown version, and not something else that's called Common Mark. But yeah, if once you find that page, there's a page that defines I believe it defines the spec, but it also has like an FAQ kind of section, and also just in general a bit of like a history and why they're working on Common Mark. It turns out that Markdown doesn't have, or prior to this, didn't have like a fixed specification, and so there would be little intricate details here and there that either made things what's the word for, like, I'm blanking on that word. Deterministic, undeterministic. They either made things undeterministic or error prone, or there would be some other issue that would arise. But uh, basically, Markdown doesn't have like, or at least, prior to this, it didn't have like a fixed standard that was being followed. So different people, they would add in their own little things here and there, and that could cause issues. So now these guys are working on this standard called Common Mark, and apparently a bunch of the people involved in this team, they've been working with Markdown in the industry, like not even just hobby projects. There's a lot of people who have been doing hobby projects as well, but you also have people who have been working in the industry with Markdown. So these people have extensive knowledge of Markdown and extensive knowledge of how Markdown works, and all the problems that you can face when you don't have like a fixed standard. So a lot of these people have actually faced these problems, and so they're probably the best people to try and solve the problem. Why was I talking about this? Okay, yeah, I was having a conversation with. Wait, hold on. This page has loaded, so I'm gonna search for the data set. The data set is called LeRoBot SVLA. Okay, LeRoBot slash SVLA. These are models. I'm looking for data set. Pick place. 101. This is the one. Okay. Right. What was I talking about? I was talking about Markdown, right? Oh, I was also having this conversation with Gemini about Markdown. Right. So, there's no fixed standard, there's no single standard. That's Okay, there are many flavors such as Common Mark, GitHub flavored Markdown, multi Markdown, etc. If browsers were to support it, they would have to pick one which could break files written in another. And then there's security issues. Converting text into rendering elements involves potential security risks like cross-site scripting. Browsers prefer to leave the parsing logic to the website of the user, to the website or the user. The design goal. John Gruber, the creator of Markdown, designed it specifically to be convertible to HTML. I didn't know that. Okay. The intent was always for it to be a source format, not the final delivery format for a browser. You know what? Okay, that makes sense. So I'm guessing what GitHub is doing before I even read that section of what that section of Gemini's answer, I'm guessing GitHub has its own rendering engine or conversion engine that converts whatever markdown you have written into HTML elements, and then it renders it for you. Let me see what Gemini is saying. How does GitHub or Reddit do it? When you view a markdown file on GitHub, you aren't seeing the browser render the markdown. You are seeing GitHub servers do the work. The server side, when you click on a MD, hold on. When you click a MD file, GitHub server side code using a library like Common Marker reads your text and converts it into a structured HTML document. The delivery, the server sends the HTML to your browser. The styling, GitHub then applies a specific CSS style sheet, their famous GitHub Markdown look, to make the headers big and the code blocks pretty. How you can render it without Pandoc. If you don't want to use a command line tool like Pandoc every time, you have a few alternatives. Browser extensions, no, I don't want to do that. VS Code preview. If you use VS Code, you can press Control plus Shift plus V to see a live render. Nope, I don't want to do that. Online editors, I don't want to do that. Okay, so I'm just gonna do the conversion because Pandoc. I have actually used Pandoc, and yeah, it's amazing. Like this, it's not just for Markdown. It's for like multiple different markup languages. So it allows you to convert those markup languages to a specific format, and that is just that is amazing to me. I'm using it specifically for Markdown, and I don't mind doing that actually. I could write a in my conversion tool because I do have a conversion tool listed here, right? Gemini Convo conversion tool. So when I was saying conversion tool, I was talking about, well, okay, what all does the conversion tool need to, okay, convert MD files to HTML files using Pandoc and organize them. Actually, yeah, I need to see how I want this entire thing to be structured, because at least from what I'm like, my way of thinking about this is okay, wait, and organize them, and then here, search utility, find a way to not show. Actually, I don't need to find a way for that. Like, I'll just not show it, right? um User types search query, um search utility gives list of pages containing that data, and then user clicks page to load convo. Now, here, knowledge base. Convert entire TUI journal um, database JSON into, and this is where it's going to get a little bit complicated because I need to convert the entire thing into multiple HTML pages. And I then need to find a way to structure that using Zola's Markdown. So I think there might be a necessity for two tools here, though I can consolidate them into one tool. It doesn't need to be, two separate tools. Okay, convert entire TUI journal database JSON into multiple HTML pages. Actually, no, it's not HTML pages. I just realized that. Hold on. Wait, back up. We need to. Okay. Note. See how to make the generated HTML files fit in with the Zola common mark workflow. Okay. Then this we converted into multiple HTML pages and organized them. And then hello, HX. Hey there, welcome to the stream. How's it going? We are currently um, doing a couple of things actually. I'm doing some research on, um, I'm actually first right now writing down this thing about, hold on, wait, let me finish this. Note, see how to make the generated HTML file fit in with the Zola common mark workflow. And then for the search utility, same thing. User types search query, search utility gives a list of pages containing that data, and then user clicks page to load knowledge base entry. Okay, right. So what we are doing is, just a second. Yeah. So what we are doing right now is looking into. Right now, I was just having a conversation with Gemini about the Markdown thing. I can close this conversation. We were also looking at the LeRoBot dataset thing. So I've opened this up. This is the dataset. I need to see where it specifies what the version, oh, there it is, code base version, version 2.1. So this is what I need to look out for. And I'm guessing that's, okay, so that's going to be in info.json. Anytime I look up one of these data sets, I need to look for the version thing. Okay, all right, great. So we are, because I don't want to get rid of this because I have to make like a social media post about this, I need to like grab screenshots and stuff. So what I'm going to do is, I think I can do it here, right? So let's deactivate first because I don't know what's activated here. I think it's Hugging Face Transformers what do you call it? Python project. Okay, dot, and then learning, LeRoBot, and this. Okay, and then we'll create another thing here as well. CD, scratch stuff, learning, LeRoBot, and this. So first thing we want to do is activate the environment. Okay. Is it not? Wait. Oh, okay. Accelerate is part of this. What does accelerate do? I think accelerate might be it might be Hugging Face or LeRobot related. Okay, then we have to do the same thing here. Env and bin and activate. Now let's open up the project here and open this up. This is our code. Hold on just a second. Actually, give me a second. Let me hydrate because oh, I've been talking for like 45 minutes. Fortunately, this time it was all related to, what we started the stream with. So I'm happy about that. And yeah, we still have like a good bit of the stream to go. I think an hour and a half or an hour and 15 minutes or whatever. I don't know. Hopefully I'm able to go for that long. But yeah, dude. Now, hold on. Give me a second. Oh, actually, you know what? This would be a good time to take a short break as well. Give me like, I don't know, 2, 3 minutes. I will be back. I'll rush back as soon as possible. All right, I'm back. Uh, yeah, okay, cool, awesome. So, where were we? I was looking at this and then I was doing this, and yeah, we are good to go. So, where were we in terms of reading this? I think we were looking at the example directly, as in we reached to the example, not directly, looking at the example itself, the example um, code itself. Here are different ways to set up temporal windows depending on your use case. Skim the options and pick one to start. Switching later is just a change to the dictionary. So I did this, right? I ran this, and now I'm trying to print out various different, what do you call it? I'm trying to print out various different things about this data set. Just a second. Okay. What was I saying? Yeah, I was trying to print out the various different attributes, I guess you can call it, of the data set object itself. So basically, what's been returned by LeRoBot dataset, that is what I'm trying to print. I also just noticed that it is not loading. This is a class that's been instantiated, right? Yeah, this is a class. Two modes are available. Hold on, let's read this. Two modes are available for instantiating this class depending on two different use cases. One, your dataset already exists on your, oh, okay, so, okay. I was actually wondering about this, so it's a good thing that they're giving the information. So, um, your dataset already exists on your local disk in the root folder. This is typically the case when you recorded your own dataset locally and you may or may not have pushed it to the hub yet. Instantiating this class will load your dataset directly from disk. This can happen while you're offline, no internet connection. And the second way is, wait, we're not on the second thing yet. Okay, so the second way that the data can already exist is on the Hugging Face hub at the address so and so, and not on your local disk in the root folder. Instantiating this class with this repo ID will download the dataset from that. Actually, let's confirm that this is the link for the dataset. Did I close that? No, I didn't close it. Yeah, that's the link. It's at huggingface.co/datasets, and then that's the repo ID. Where was I? Yeah, instantiating this class with this repo ID will download the dataset from the address and load it, pending your dataset is compliant with Codebase version 3.0. If your dataset has been created before this new format, you will be prompted to convert it using our conversion script from version 2.1 to version 3.0, which you can find at LeRoBot so and so so and so. I'm glad that they have this conversion tool, so it makes it like seamless to convert whatever data set you might have had. Okay, the second use case is your data set doesn't already exist either local disk or on the hub. You can create an empty LeRoBot dataset with the create class method. This can be used for recording a dataset or port an existing dataset to the LeRoBot dataset format. In terms of files, LeRoBot dataset encapsulates three main things: metadata, um, and what else? Hold on. Okay, I'm a bit confused about the way that this is written out. It says it encapsulates three main things. One is metadata. Oh, okay. No, I'm not. Yeah, okay, that's my bad. I wasn't looking at this. So, three main things: metadata, HF dataset, and videos. Metadata contains info contains various information about the dataset, like shapes, keys, FPS, etc. States stores the dataset statistics of the different modalities for normalization, and tasks contains the prompts for each task of the dataset, which can be used for task conditioned training. Then HF dataset from datasets.dataset, which will read any values from par- from Parquet. I need to look into what Parquet files are. Um, then videos, optional, from which frames are loaded to be synchronous with data from Parquet files. A typical LeRoBot dataset looks like this from its root path. You have data, meta, and videos. Oh, also observation.images.laptop, images.phone, and images.zone. So I need to look into this naming this thing. Yeah, the the naming convention thing. Like, what is it relating to exactly? Okay. Note that this file-based structure is designed to be as versatile as possible. Multiple episodes are consolidated into chunked files, which improves storage efficiency and loading performance. The structure of the dataset is entirely described in the info.json file, which can be easily downloaded or viewed directly on the hub before downloading any actual data. The type of files used are very simple and do not need complex tools to be read. It only uses .parquet, .json, and .mp4 files, and .md for the README. Okay, all right, cool. So this thing gets loaded. I think at this point, if I set up, how had I done that? I forgot what the thing was for slime. What um, slime config, Control C and then V. Slime region send, slime send cell, send to REPL. Okay, and then slime region send. All right. Yeah, there it is. So in this case, I would need to send this to, I need to have a REPL open, meaning I'm gonna need to, actually, no, I just need to install IPython in this environment. I think that's all I need to do. Install IPython, and then I can open up the REPL. But the thing is, the REPL needs to be loaded somewhere. Um, Back up. Let me go to another thing here. Tmux ls. What all sessions do I have here? I have Temperos Learning. I think I can go into Temperos Learning is where all the Gemini conversations are open. I can repurpose Nano. I think yeah, I can repurpose nano. Um, let's come here and actually not here. I need to come over here and give me a second. Let me just, I think it's this one. Yes, okay. So need to, we need to detach from, wait, we are not in Tmux. Okay. Tmux attach to nano. All right. What all do I have set up here? Okay. All right. So we go back here, CD into learning LeRoBot, and then this, and we need to activate the environment, bin, activate, and here we need to do UV, why did I write it like that? UV pip install. UV pip install, I think this is all I need to do, right? IPython, hopefully. Okay. And then now can I just open up IPython? Right, there it is. So this is our IPython session. I've completely forgotten about how I was doing stuff in Vim Slime. So give me a second while I try to remember all of this again. It was, so Control C and then V for config. In the config, I need to, yeah, I need to pass in, I need to, hold on. So I need to first import the data set. I need to import, well, LeRoBot data set. Then I need to run this, and then I need to run this. So I need to keep in mind that whatever I'm typing in this, um, whatever I'm typing out in this script, it's not the script that's being executed. It's the code blocks, the code chunks that are being executed. And yeah, okay, hold on. I need to, I'll open up Gemini and ask Gemini to give me like a rundown. Hey, I used to use Vim Slime in my nvim lazyvim slash tmux setup. I can't seem to remember what code I had used to config Vim Slime to send a block of code, a block slash line of Python code to another tmux tmux sessions window where there is an active IPython session running. Because that was the thing, like you mainly what we were going to be using here is the ability to send key presses to, actually, okay, no, hold on, because there was Vim Slime was handling a little more than just that, but Vim Slime was helping us send this entire block of code, and then we would be using a specific key sequence to, like, um, I guess enter it. I'm not sure, but you also need to specify the what do you call it? The the session name, the window number, the pane number within that window, and then I guess I can't remember. Hold on, I'm just gonna read. Okay, nvim, Lua, plugin, Slime. I had done this as well, right? So let's try to open up. How do I get to the config files? Would it be under lazy? No, it wouldn't be under lazy. Would it be under lazy? It's not under lazy, no. Um, how are we getting to the config? Okay, let's go to files. I think there's a config thing here, right? Oh, find config files. Right. Slime. Great. Awesome. So map this key to send the current cell. Description, send to REPL. Okay. All right. You can add key maps. Okay, this handles sending an entire cell, and we denote a cell using a certain key, using a certain like character. I think this is the delimiter. This is how you denote what is a cell, and I guess it's going to send from there up until either the next time it finds a delimiter or until the end. There was also another thing for sending only a line. But yeah, okay. Socket name default. What is socket supposed to be? I need to hold on. Let me look at the thing here. Okay, to make Vim Slime work seamlessly with Tmux and IPython, you need to tell it to use the Tmux backend and ensure it handles the bracketed paste, the bracketed paste mode that IPython requires to avoid indentation errors. Socket name default, target pane last. Okay, okay. How to use it. Select target. The first time you hit Control C, Slime will ask you for a socket name, target session, and pane. Have I, in my thing, have I mentioned, okay, the target is already Tmux and Slime after send. Okay, okay, all right. And then there's the bracketed paste as well. Awesome. All that is already handled. Target. If you are in the same session, you can usually just type 1 or 1 for window 1 or .2 for pane 2. Sending code. Okay, the IPython magic, Slime Python, IPython. Because we set so and so, Slime wraps your code in C paste automatically, which prevents the auto indent. Have I done that? I don't think I've done that specific thing. Yeah, I don't think I've done that specific thing. Okay. Wait. Control C, config. Okay, I guess default. Tmux target pane. Uh, the first time I hit Control plus C and V to actually configure Slime, I have to enter um, the, I forgot what that thing was. Hold on. Control C, V. The socket name, and then Tmux, um, Tmux target pane. I'm not sure what to put here. There was also a thing where I'd like set up this entire this entire like key sequence where I forgot what exactly I was using that key sequence for. I think it might have been to easily create. Oh, that was a different thing. That was to easily create. easily split up the tmux window into multiple panes so I can then display images in each of those. Okay, when you trigger vimslam for the first time, it essentially asks, where am I sending this code? Here's exactly what you should type for those two prompts. Socket name default, just type this and hit enter. Unless you are doing something very advanced with multiple tmux servers, the answer is almost always default. Note, if default doesn't work, it's because your environment variable is set differently. You can verify it by running echo so and so. Okay, let's try that. Let's come here. Okay, cool. 95% of the time, 99% of the time, default is the one. Okay, tmux target pane. So we have session, which is currently called nano. Let's also um, hold on. So this is stream laptop. Stream laptop is not being used right now, so I can disconnect from this and attach to this. And then here I want to do rename session to LeRoBot IPython. And that's changed. Great, awesome. Okay, the quick way. So it's the format is session window pane, and in this case, I'm doing it on Windows 0. Session is LeRoBot IPython. So let's enter that over here. LeRoBot IPython, Windows 0, pane 0. This sends it to window 1, pane 2 of the current session. This sends it to the this sends to the pane to the right of your current one. Last, this sends to the pane you were just in before switching to NeoVim. I think this is it. Yeah, I think this is it. Now, let's come here and test this out. I don't know if that worked. Yeah, I don't think that worked. Socket name. Let's go with default. Yeah, let's do it again, I guess. LeRobot IPython window 0 pane 0. Oh, there it is. Okay, right. So it worked. Awesome. Give me a second here. Okay, so now that that is done, we can send this as well. Amazing. And send this. Okay, and then first things first, let's print out this. That's a dictionary, right? Great. Next, we can try to, wait, this is a dictionary, right? So what we could do is print dataset o1.features. I don't know how heavy this is going to be. All right, this is our dictionary. Can I get like a pretty print of this? I'm not sure. Is there a way to get a pretty print of this? Do I have pretty print installed? pprint. Support to pretty print lists, tuples, and dictionaries recursively. Very simple but useful. Okay, hold up. Okay, classes. Pformat. Format a Python object into a pretty printed representation. Pprint. Okay, all right. As pp. And now here we're going to do pp.pprint. Okay. Yeah, we need to do this. And now do this. Awesome. There it is. So now we can come here and read our entire thing. So we have action and then observation.images.up, observation.state, task index, timestamp. Okay, dude. Shout out Vim Slime, man. Holy shit, this is crazy. Like this really helps. This enhances the workflow big time. Because otherwise I would have to, like, each time I wanted to run this, I would have to like do this and then, Python 3.10 and then this, which now I guess it might, yeah, there you go. So each time I would have to do this. Instead, I can just do it here. So this entire script becomes like a scratchpad kind of thing, and I can just select lines that I want to run. I can also add that, I forgot what the, so we have this, and I think it was this. I think so. What was the slime? Okay, this is slime paragraph send. Let's, for the sake of testing this out, let's do print ABC and have this be a separate thing. Okay. This is not sending what, oh, there you go. This sends the entire cell. This sends the entire cell, and we know that it's sending only this cell because it's not printing ABC. Whereas if I remove this and then try, should my cursor be at like the top here? No, let's try this. Okay, there you go. Yeah, it executes the entire cell. Great. Okay. Now, I need to refresh my knowledge on. I'm glad that I didn't have to like set up Vim Slime all over again with all the configuration and all of that stuff. I'm glad that, just having that in this config file, it just solved a whole bunch of issues for me. And yeah, yeah. Stream desktop 00. By default, it's sending to this. And right now I'm sending it to LeRoBot IPython 00. Which, I mean, I could have just sent it to Stream Desktop 00 as well. Yeah, why am I not doing that? Why am I complicating this? Because I have Stream Desktop set. Well, okay, yeah, whatever. It's fine. It's fine. What more did I need to do? Oh, okay, yeah. One problem that I have here is that now I can only see one or the other. I can't, though it's fine. I mean, you guys will be able to see it on stream, so that's okay. I can just, you know, look at the other window and I'll I'll see the output. Actually, I could set up tmux. I could actually SSH into the thing and have the tmux session be shown on another screen of mine. That's not an issue. But yeah, okay, let's continue with this. So what has happened here? Streaming large data sets. Okay, I was expecting it to explain something about this, but I guess it's not doing that. I do need to, hold on, wait. Let's come here and look at the data set. So we have action, which contains a dictionary with the type, the frame rate. The action has frame rate. Episode has frame rate. Oh, they all seem to have like a similar kind of thing going on, where so action has D type, frame rate or FPS, names, and then shape of the tensor. Episode index also has D type, FPS, name or names and shape. Frame index also has the same thing, the same number of fields. It's like a similar dictionary. Actually, it is the same dictionary. Index has the same thing as well. Observation, hold up. Observation is different. Observation has video and then info and then names and shape. And then task index and timestamp are both the same as the other one. Okay, all right. Streaming large data sets. When to use streaming? When the data set is bigger than the available storage. So stream data sets that don't fit on your disk. Experimentation. Quickly try different data sets without downloading. Then cloud training. Reduce startup time by streaming from the Hugging Face hub. Network available. Requires stable internet connection during training. Okay, performance. Streaming achieves 8 to 10 IT per second. Is that iterations per second? Also, I said 8 to 10. No, it's 80 to 100. 80 to 100 iteration. I'm assuming IT per second is iterations per second with good connectivity. This is on average comparable with locally stored datasets, factoring out initialization overhead. Okay, download dataset. Faster training requires more storage. All right, we already did this part. And then sample fastest access after download. Let's do that here. Okay, we have, actually, wait, dataset 01. Let's just do 1. So what are we looking at here? Okay, this returned a dictionary with observation.images.up, observation.images.side, observation.state. Why is it, hold on. Back up. I didn't do pp.prettyprint. Is there a way for me to like alias this? Oh yeah, I think I can. From uh pretty print import. Yeah, yeah, that's the same thing, right? Import pretty print as pp, and then we need to run this, and then we can do this. That works. Great. And then there. Pretty print. Wait, pretty printing has been turned off. What? Why did that happen? Okay, I don't know what that was all about. Okay, this is our data set. So we have action dot is pad, episode index. All of these are tensors. Okay, frame index observation dot images dot side. Okay, task. Pink Lego brick into the transparent box. Pink Lego brick into the. Oh, did they mean pick Lego brick into the transparent box? Okay. Or maybe the Lego brick is pink and they're just saying that, this brick has to go there. I am interested in finding out like how the human readable version, the human readable instruction affects the training. I'm definitely interested in checking out how the basically like when we are just using words and we are not using numbers, like how are these words factoring in? How are these words affecting the training? Or it could just be that this is for our understanding. This is for the understanding of the human that's seeing this data set. So this is just a human readable description. It's not really gonna affect the training. That's a possibility as well. Okay, so just like this, we have multiple things. Um, we can try loading. Okay, let's try loading 0, or let's try loading 10. Wait, this is interesting. Right now this is in this mode, right? I I'm glad. Um, oh, I think we are live. Yeah, we are live. So that's a bummer. We disconnected, and by the time I noticed the disconnect protection had ran out. So that sucks. But it is what it is. We got a good like 1.5 hour stream in before that happened, so I'm happy with that. And we are gonna continue. Right. So did I switch? Yes, I switched. Awesome. So where were we? Yeah. So what I was wondering um, is this entire data set just for that one task, which is pink Lego brick into the transparent box? That's kind of interesting. Let's see if there's more like information here. This data set was created using LeRoBot. Okay. Video path. There are video files here. I could write something to maybe display the the video frames. Where does it mention the task? So this is okay. We have a split here. Oh God, things are slowing down. Hold on, give me a second. Okay, all right. Let's scroll here. So we have action, observation, and task is probably going to be mentioned somewhere here as well, right? Task index is 0. Task index is 0. Where's the task itself? Maybe, okay, maybe it doesn't print out. Yeah, maybe it doesn't print, what do you call it? The string stuff. Could that be it? Or maybe I just missed. Yeah, because I'm seeing the other stuff, but I'm not seeing. Okay, there's observation images. There's episode index. Action is pad. That is missing as well. Yeah, yeah. Okay. So maybe it's not showing all of the stuff. I'm guessing if I open it up in Data Studio, then I'm probably going to see it. But Data Studio is going to be quite heavy to load on my current machine. So I'm going to load it up. I'm going to load it up separately. Where is task mentioned here? Is task being mentioned here? Yeah, I'm not sure. Okay, all right. We can continue with this. So, training integration. You can easily integrate regular and streaming data sets with Torch data loaders. This makes integrating any LeRoBot dataset with your own Torch training loop rather convenient. Because we fetch all frames from the datasets as tensors, wrapping wrapping iterating over a dataset with training is particularly straightforward. PyTorch data loader. You can easily integrate regular and streaming datasets with Torch data loaders. This makes integrating. Okay, wait. I've already read that here. Okay, right. Data loader. Right. Okay. Okay. Then device. All right. Oh, dataset. We are passing. Okay, we can pass dataset directly into data loader. That's interesting. Okay. Then observations equals batch so and so. Okay, okay, okay. All right. Why this matters. This simple API hides significant complexity, multimodal synchronization, images and sensors perfectly aligned, efficient storage, compressed videos, memory mapped arrays, temporal handling, easy access to observation slash action sequences, and scalability. Same code works with small and massive datasets. Compare this to traditional robotics data handling, which often requires custom parsers for each data format, manual synchronization across modalities, complex buffering for temporal windows, and platform specific loading code. Okay, LeRoBot dataset standardizes and simplifies all of this. Definitely, I can definitely see how that's helping here, because if you are training something from scratch, or even I think even the process of fine tuning is basically training, but not from scratch. You're just training whatever is not frozen, and also whatever extra layers you've added. But I believe the training process is more or less this. Well, actually, no. The training process also involves this. Yeah, okay. This is what I was about to talk about. I was about to say that it involves, actually running the model and calculating the loss, and then doing back propagation, and then doing optimizer.step to optimize the values, to change the weights essentially. But yeah, this is what your training loop would look like. And being able to just plug the data set directly into data loader and have it just work here with a few minor changes, that's great. That is actually amazing. And that's making me think that I should go back and learn about dataset and data loader in PyTorch as well. Because I mean, anyways, I'm gonna have to do that when I'm, learning, um, or relearning, or whatever. When I'm relearning feed forward neural networks and learning convolutional, recurrent, and transformer based neural networks. Yeah, I feel like I'm going to be using the data loader thing a lot there. Ooh, you know what I should look for? I should see if there are, hold on. Hugging Face data set, PyTorch data loader. Use with PyTorch. Tensor objects out of our data sets, and how, what? No, I think something is missing there. But yeah, okay, they have their datasets library, which, okay, this document is a quick introduction to using datasets with PyTorch, with a particular focus on how to use torch.tensor objects out of our datasets, and how to use a PyTorch data loader and a Hugging Face data set with the best performance. Maybe I could open that up here. Yeah, yeah, yeah. Okay, hold on. Let's open this. Actually, it would be much quicker if I just typed out the entire thing instead of trying to go through the whole. Okay, huggingface.co/docs/datasets/en/use underscore with underscore PyTorch. Okay, give me a second. Let me just make sure this thing loaded. Yes, it loaded. Awesome. So we're going to transition back here and read this. Because as I'm learning about feed forward neural networks, recurrent neural networks, convolutional neural networks, and transformer based neural networks, I I kind of want to be able to use data sets from Hugging Face Hub, because there's a ton of data sets on there. PyTorch itself does provide a couple of data sets, but I was like, okay, why not directly jump to, you know, Hugging Face? Um, because I'll have a wider selection there. I'll have a wider choice there. But yeah, okay. This document is a quick introduction to using datasets with PyTorch, with a particular focus on, hold on how to get torch.tensor objects out of our datasets, and how to use a PyTorch data loader and a Hugging Face dataset with the best performance. Dataset format. By default, datasets return regular Python objects such as integers, floats, strings, lists, etc. I didn't know that. Okay, I thought it has like a fixed format. To get PyTorch tensors instead, you can set the format of the dataset to PyTorch using dataset.with format. All right. A dataset a dataset object is a wrapper of an arrow table, which is a fast zero copy, which allows fast zero copy reads from arrays in the dataset to PyTorch tensors. Give me a second here. Just have to do something real quick, and yeah, we're good. Okay. To load the data as tensors on a GPU, specify the device argument. Okay. Oh, ds.with format. That's where you specify the device. Okay. All right. Wait, give me a second here. I just need to load something else elsewhere. Okay. Right. Great. Wait, where is the wait, okay. We have device and then we have ds.with format, then we have device and then ds0. We could do this right now, right? I think I'm not sure. Just a second. Let me see if I don't think we have data set. We probably do have data sets installed, right? Import data sets. So we have data sets here. So we do from datasets import dataset. Okay, dataset dot from dict and then torch. Okay, we could do that instead of loading the. So let's do that. Okay, that's done. And now we can do this. So data equals this. So this is just our list of lists. And then we do ds equals dataset dot from dict. And here we are supposed to specify a dictionary. Data. Let's leave this thing here so we can expand later. Actually, do we need to expand? I don't think we need to expand. Though I do love that I sorry. I do love that the trailing comma is like a nice easy sort of shortcut to expand this if I need it to be expanded, and then I can also save and get rid of it. Okay, ds equals ds dot with format torch. All right, and then ds0. So we're going to save this and run this entire block and see what we see here. All right, okay, cool. And let's try this. Let's take it to the next line. Okay, great, awesome. Yeah, let's just print this alone. Actually, this is supposed to be a range. Backup. No, hold up. Invalid key. So, oh yeah, it's 0 and 1 because, yeah, there's only two of those. Yeah, okay. So, the end here is exclusive. It's not inclusive. And that's why we get this. Give me a second. Okay, great. So, what's next? Wait, so this is now a tensor, isn't it? Like, what would this be classified as? If I try to print out type ds, what are we looking at here? This is a data set. This is not a tensor, but we can then access, how do I see like is there a features thing here? There's a features thing here. Let's take a look at that. Okay, not what I was expecting. I also need to remember to do this. Okay, what comes after features? What is, no, hold on. What is this? Oh, let's get the type. Let's get the type of it. Okay, it's a type called features. All right. This is what? No, hold on. What is this? This is datasets.arrow dataset.dataset. I'm trying to see if this has been connected to Torch yet or not. Also, why am I getting this? Why is there a warning here when the thing is being used? Redefinition of unused. Okay. Where did I mention data? From line 4. From line 4. Oh, torch utils.data. Okay, let's get rid of this. Let's save. Now let's do that and then do that. Okay. All right. Then what's next? So this is where we do, well, no, we're already done with this, right? The next thing was not for like general PyTorch. That was specific to GPUs. If you wanted to do GPU stuff specifically. Then n-dimensional arrays. If your dataset consists of n-dimensional arrays, you will see that by default, they are considered as the same tensor if the shape is fixed. That by default, they are considered as the same tensor if the shape is fixed. I'm having a hard time wrapping my head around that. If your dataset consists of n-dimensional arrays, you will see that by default, they're considered as the same tensor if the shape is fixed. As the same tensor as what? Like what same tensor are we comparing it to? Yeah, no, I'm kind of confused about that. Hold on. Okay. All right. So, just a second. Yeah, cool. Okay, this is fixed shape. Oh, there's a difference there. Yeah, there's a difference there. Wait, why is that? So here we have, what is this? A three-dimensional array, I think? Hold on. Let's change this up to be 3. Okay, so initially we were one-dimensional and two-dimensional, and then now we've become three-dimensional, right? I think so. Yeah. Just to help me visualize this, let's do that. Oh, can I also do the trailing comma here to, yeah, okay, I can. Okay, this is what we are looking at. So that's a two-dimensional array, right? And then that gets wrapped into one more dimension, so it becomes three-dimensional. All right, okay. Sorry about that. Zoned out. Um, Wait, so what's the difference between these two? Oh, okay, varying shape is here. And that's probably what they meant by n-dimensional. Okay, I thought they were talking about, multiple dimensions above, but no, here they're talking about like if we actually what happens if I convert this? Okay, so let's say data underscore t equals I do not have, okay, that'll be auto imported. Let's just go up here and make sure. Yes, import tensor. Is it supposed to be this tensor? No, it's supposed to be this tensor. Auto import that as well. Actually, I want to see if it still says auto import after that. Now it doesn't say that because, okay, all right. Hold on, I need to learn to recognize when each of these is going to be auto importing, at least in Python. So let's do, hmm, okay. And then, okay, so it's just mentioning that yes, it's good. Oh, so anytime I see the namespace on like the right side, it's going to be auto importing. And if it's already imported, then it's not gonna show the namespace. Okay. Tensor. How do we initialize a tensor? I forgot. I think we just pass in a dictionary, right? No, a tensor doesn't take in a dictionary. It takes in a list which can contain multiple other lists. All right, let's, actually, I could print it out here and then do pp uh, data underscore t. Okay, tensor is not defined. That is fair because I did not do this. Now it should work. Okay, that's our tensor. Hold on. This is kind of interesting. I just realized this. It is, in this case, it is breaking it up. Yeah, in this case, it's breaking it up into multiple tensors. It's not just one tensor. So let's try a different data object. Okay, actually, okay, let's copy this entire thing and paste. Delete this, and this can be data O2. Now here we're gonna do this. I don't know if this will even work because the size is not proper. Expected sequence of length 2 at dim so and so. Okay, that's good. That's good. So it handles when your data has varying shape, then it handles that for you. So in this case, if I tried to do um, let's okay, instead of this, we can do um, this. So data underscore t equals dataset dot from dict. And in this case, we are passing it. So this is interesting. So we generate a dictionary, and this is all we pass into the dictionary. And then we do this equals this dot with format torch. What did that print out? Printed out dataset. Hold on. With format, okay, and then okay, let's try accessing this then instead. Right, there it is. There it is, but it's not showing what I was expecting it to show. Um, did I miss something here? No, I think we're good. Yeah, I'm not sure what's the issue here. Or what's different, I should say. I'm not sure what's different here. Oh, this is what's different. I didn't feed in the data that's supposed to be fed in. There we go. Now we get the result that we are looking for, and that is two separate tensors. Right. However, this logic often requires slow shape comparisons and data copies. To avoid this, you must explicitly use the array feature type and specify the shape of your tensors. You know what? Okay, we don't need to test that out. That's more advanced cases. Features, class label. Okay, class label. Okay. When it comes to wait, let me try asking this question to Gemini. I'm learning deep learning uh, through PyTorch, HF transformers, HF datasets, etc. PT has a data loader and dataset uh, type of its own. I'm wondering if I should focus more on PT's dataset or HF's dataset? Uh, hey there, Tan dude. Hello, hello. Welcome to the stream. I am. It's a mix. Hold on. So you asked what OS I'm using. Let me explain here. So I'm streaming off of Windows, right? But the two windows that you see in the bottom left and bottom right, they are both running on Linux. So the in the bottom left, you see what you're seeing is the Windows terminal, but the Windows that through that Windows terminal, I'm running Ubuntu, and from that I'm SSH'd into my one of my Linux machines, and I've basically connected. I've attached to one of the tmux sessions that's running on that Linux machine. And then in the bottom right, the window that you're looking at, that is being captured from my Linux machine and streamed over to this machine over RTMP. And then in the top right is just the browser that's running on Windows. But yeah, welcome, welcome. We are currently looking into a bunch of things actually. Right now, specifically, I'm looking into whether I should give more of my time to PyTorch's dataset type or Hugging Face's datasets type. Because, I mean, I don't think, to be fair, I don't think the dataset thing in PyTorch is like all that complicated that I can't, learn both HF datasets and PyTorch datasets. But I just want to see. Okay, Gemini is saying it's a common point of confusion because they share similar names, but they actually serve different roles in a modern deep learning pipeline. The short answer is focus on learning HF dataset library for data manipulation, but keep the PyTorch data loader for the actual training loop. That makes sense. Yeah. So we are looking into we are actually looking into both of them. At like keeping that in mind, we're kind of looking into both HF dataset and PyTorch data loader, not necessarily PyTorch data set. Because in this case, I'm able to use the data loader and then pass that into um, an HF dataset. Or rather, I think I'm first downloading an HF dataset and then, oh, yeah, no, my bad. I'm downloading an HF dataset and then I'm able to pass that into a PyTorch data loader, which, hold on, I don't know. Let's go back here because they didn't really go into the data loader thing. This is talking about using it with PyTorch. Um, so this is not using data sets right now. This is just, yeah. Right now it's not, and at least in these examples, it's not using it's not using a data set that was downloaded from the HF hub. Okay, features, dataset features, audio, image. What is being covered here? The image and audio feature types are also supported. String and binary objects are unchanged since PyTorch only supports numbers. Class label data are properly converted to tensors. Okay. Um, yeah, sorry about that. Got a bit distracted. Okay, so moving on from this data loading. Okay, cool. Like torch.utils.data.dataset objects, a dataset can be passed directly to a PyTorch data loader. Okay, from datasets import dataset. Uh, data loader. Okay, all right. So we create a random data thing. Great. Then we create labels. And then we do from dict, okay, data label so and so with format. I didn't even think about doing that. Yeah, I forgot that this is a thing, because whatever this is returning, we would then be able to call this method on it anyways. So I don't need to do it in a different line. I can just do it in the same line. Okay. Data loader equals data loader so and so batch size 4. All right, cool. So I kind of do need to familiarize myself with data loader at least, because I'm going to be using PyTorch to do the training. And I believe, like, anytime I'm doing fine tuning as well, I don't remember what the fine tuning process looks like through Hugging Face, so I don't know what kind of training loop I have to um, set up when I'm fine tuning through Hugging Face using the PyTorch backend, because I'm mainly only using the PyTorch backend. I'm not touching TensorFlow. But yeah, I need to see what the training loop looks like if I'm fine tuning through Hugging Face's own like trainer API and stuff. Okay, optimize data loading. There are several ways to increase the speed your data is loaded. This to increase the speed your data is loaded, which can save you time, especially if you're working with large data sets. PyTorch offers parallelized data loading, retrieving batches of indices instead of individually, and streaming to iterate over the dataset without downloading it on disk. Use multiple workers. You can parallelize loading with the num workers argument of a PyTorch data loader and get a higher throughput. Under the hood, the data loader starts num workers processes. Each process reloads the dataset passed to the data loader and is used to query examples. Hold on. Each process reloads the dataset passed to the data loader and is used to query examples. Reloading the dataset inside a worker doesn't fill up your RAM, since it's simply okay. That's I was about to ask that question. Like, is that not going to be slow and memory consuming? But no. Since it's simply, as I was reading this whole thing, I was immediately thinking about how is multi-threading being supported. But then I remembered that PyTorch is Python bindings for the Torch library. The Torch library is a C++ library. So maybe that's how it's handling maybe that's how it's, no, actually, hold on. No, okay, so I'm right about the bindings part, but like, I'm wondering if that is the reason why it's able to do multi-threading, or the reason could be simpler, because like, okay, it is starting a separate process, right? That's possible through Python as well. Multi-threading is a little complicated in Python, but it does have APIs for like having a separate process. I'm curious about this. Hold on. Does data loader itself? Yeah. Okay. Let me ask Gemini. Give me a second here. Oh God, dude, this is gonna. Yeah, yeah, that's my fault. I need to learn to wait for the page to load, because there's that shortcut, Control Shift O, which fortunately, um, the developers of Gemini, they set it up so now even on Linux Firefox, you are able to do Control Shift O, and it um, it basically creates a new conversation for you. But the problem is, um, in my case, it's not like a general problem, but like the problem is, if if you do the shortcut before the page is loaded properly, then it's gonna apply that shortcut to Firefox itself and not to the Gemini app that's running within that tab. And as a result, that shortcut, at least on Linux, I don't know if that's the case on Windows, but at least on Linux, Control Shift O opens up some kind of library or something, and that causes like a whole thing. Okay, all right. In PyTorch, how does data loader how does loader spawn multiple processes to okay, let's say num underscore workers processes to load data. Is the is it being done on the Python level or the C++ torch level? Oh, I just realized that I wrote on the PyTorch level, not on the Python level, even though I was saying Python level, though it's more accurate to say like PyTorch level or the C++ torch level. Okay, so to understand how PyTorch handles multi-process data loading, we have to look at the intersection of Python's multiprocessing capabilities and PyTorch's underlying C++ engine. The short answer is the spawning of workers happens primarily at the Python level, but it relies on the C++ hooks for memory efficiency and data sharing. The Python level multiprocessing, when you set num workers, so I think I was right about this, that it's doing the at least the spawning of the processes. It's doing it on the Python level, and then the rest of it, it's doing it like the actual like reading of the data set and returning specific sections and stuff like that. It's probably doing that on the C++ level, which is why it's able to do it much more faster. Okay, when you set num workers greater than 0, the data loader does not use standard threads due to Python's GIL. Okay, that makes sense. Instead, it uses Python's multiprocessing module, spawning. The data loader creates multiprocessing data loader iter, creates a multiprocessing data loader iter. This class initializes num workers instances of torch.multiprocessing.process. The loop. Each worker process runs each worker process runs a loop that pulls samples from your dataset and puts them into multiprocessing.queue. Start method. Depending on your OS, PyTorch uses fork on Linux or spawn on Windows and Mac OS. The C++ level shared memory. While Python manages the processes, the data transfer happens at the C++ level to avoid massive overhead. If PyTorch used standard Python pickling to move data between processes, um, where was I? If PyTorch used standard Python pickling to move data between processes, it would be incredibly slow and memory intensive. Torch.multiprocessing. This is a wrapper around the standard Python module. Its secret sauce is that when a tensor is sent to another process, it says when a tensors. So I'm guessing tensors might be like a, hold on. Is tensors like a collection type to represent like an array of tensors? Or was that just like a, maybe that's just a typo. Okay. Oh, made a mistake. Give me a second here. Damn, I just noticed the time. Holy shit. Despite the little crash that we had earlier, which was, I think that might have been a 1.5 hour stream. I'm not sure. I think so. I think that was already 1.5 hours in. Now we are 45 minutes more. So this is like a 2 hour and 15 minute stream so far, which is awesome, dude. Okay, shared memory. The underlying C++. Wait, no, 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 back up. There was something more here. Yeah, instead it moves a file descriptor or shared memory handle. Wait, what did that say? This is a wrapper. This is a wrapper around the standard. What? Standard Python module. My God. Standard. You're kidding. Anyways, okay. It's secret it's words. Its secret sauce is that when a tensor is sent to another process, PyTorch doesn't move the data. Instead, it moves a file descriptor or shared memory handle. Shared memory. The underlying C++ storage of the tensor is placed in shared memory. The worker process writes the data into a memory mapped region, and the main process reads it directly from the same memory address. Hold on. The worker process writes the data into a memory mapped region, and the main process reads it directly from the same memory address. How they work together. Here's a sequence of events when you call next iter data loader. Main process. It sends a fetch command to the worker via a index queue. Worker process Python slash C++ runs your dataset get item dataset.get item. If it returns a tensor, the C++ backend ensures that tensor is stored in shared memory. Sorry, zoned out. Okay. If it returns a tensor, the C++ backend ensures that tensor is stored in shared memory. The worker sends the metadata of that tensor back to the main process. Then in the main process, C++, it receives the metadata and reconstructs the tensor by pointing it to existing shared memory. Note, this is why you often see shared memory errors like bus error on Linux if your uh, dev slash shm partition is too small. The C++ layer is trying to allocate space for workers to talk to the main process. Okay, all right. I think I need to spend some time messing around with both Hugging Face datasets and PyTorch data loader just to kind of like familiarize myself with both of them and get a little more comfortable with it. I don't I probably don't need to pay too much attention to PyTorch dataset unless I want to load something directly from PyTorch, like something that's being hosted directly by PyTorch, or even something that's part of the PyTorch library itself. I think they have like smaller datasets that are part of the PyTorch library, but I think usually you are downloading stuff. I think so. Yeah, at least with like the bigger ones, you're usually downloading the datasets. Um, okay. PyTorch dataset versus Hugging Face dataset. The primary difference is that PyTorch's dataset is a class structure you must implement. Oh, I forgot about that. I forgot about that. Dataset is also a specific like class because you can take any dataset. That's one of the things that they were talking about when teaching about datasets and data loaders is that you can implement a dataset for any sort of like collection that you have, any sort of dataset that you have. You can implement a dataset. You can implement like a PyTorch dataset type for it. So then that data set can then be loaded by the data loader. So there's like a specific design that you have to follow there. Okay, PyTorch dataset versus so and so. While Hugging Face's dataset is a data format slash container optimized for speed. Okay, when to use which? Use HF datasets if you are working with text for transformers, common computer vision datasets, or any dataset hosted on the Hugging Face hub. Its .map function is incredibly powerful for tokenization and pre-processing because it supports caching and multiprocessing out of the box. I should keep that in mind. It supports multiprocessing out of the box. Use PyTorch dataset if you have a highly custom data format that doesn't fit a tabular structure, or if you are doing low-level research where you need absolute control over how every single byte is read from the disk. The secret truth, they work together. You don't actually have to choose one over the other. In a standard transformer pipeline, you use HF dataset to load and pre-process your data. Then you simply wrap it so the PyTorch data loader can read it. The standard workflow looks like this. You load the dataset using dataset load dataset, then process dataset.map tokenization function, then format dataset.set format. This makes the HF dataset act like a PyTorch dataset. Let's hold on. Let's just confirm this little doubt that I have here. So when we do with format, what does no hold on. With format, okay, right. So we have created data T, right? We're gonna do. Should we just like load the entire? Well, yeah. I mean, at this point we can, right? So let's load data underscore T and then pp type data underscore T, and then let's yank and paste the same thing here. So let's run this entire code block and see what we are looking at. Okay, so we ran it and we have our data set from dict. This is what I find kind of interesting. We are specifying stuff here, and these things become features. So if you look here in dataset, it has features, data. I thought data meant something. Maybe it doesn't mean anything. Maybe like I could probably just pass whatever name I want. Though, to be fair, maybe some of the other functions, maybe something that's relying on this data set might be relying on a specific naming convention. I'm not sure about that part. I'll have to check. I'll have to see like how that can be affected. But for the most part, I think yeah, I don't know. I don't know. I was about to say that maybe the name doesn't make a difference. Like I could give it ABC and that'll be fine. But even if that's fine right now, maybe it might not be fine for, other situations where something is expecting a specific naming convention. Anyways, so we have our data set, and currently this is datasets.arrow dataset.dataset. All right. Then after we have done with format, at that point, it's still datasets.arrow dataset.dataset. I was expecting it to be something PyTorch related. Well, anyways, format, torch, okay. This makes the HF dataset act like a PyTorch dataset. Okay, so I have a question here. Okay, I'll ask that question later on. Now ending the conversation with Gemini, my recommendation, prioritize Hugging Face dataset for now. If you are learning transformers and modern NLP slash CV, the HF ecosystem is the industry standard. It handles the boring parts of data science, cleaning, tokenization, caching, so you can focus on the fun parts, training and architecture. However, you should still understand the PyTorch data loader, even if you use HF for the data storage. The data loader is what handles shuffling, batching, and sending data to your GPU during the training loop. Okay, so my question is relating to this. Let's copy this and come here. Explain to me why the datasets type is still this before and after I use with underscore format. It's perfectly normal for the type to remain datasets.arrow_dataset.dataset. This is a common source of confusion, but it highlights the core design philosophy of the Hugging Face library. The reason the type doesn't change is that with format does not convert the underlying dataset or the object itself. It only changes the view of the data when you access it. It's not a wrapper, it's a conversion. No, it is a wrapper, not a conversion. Think of HF dataset like a universal remote. Even if you program the remote to control a Sony TV or a Samsung soundbar, the remote itself is still the same physical object. The under the hood, the data is always stored as an Apache Arrow table on your disk or in your RAM. This is why the class name contains Arrow. The interface, when you call with format torch, you are just telling the datasets get item method. When I ask for a row, don't give me the default Python list. Convert that specific row to a PyTorch tensor on the fly. Efficiency, why it's a good thing. If with format actually changed the object type to a PyTorch tensor, the library would have to load the entire dataset into your RAM, convert every single entry into a tensor, and duplicate the memory usage. By staying an Arrow dataset, it can keep gigabytes of data on your disk, gigabytes of data on your disk through memory mapping, and only consume a tiny amount of RAM needed for the current batch you are training on. Okay, that's interesting. I didn't know that. This is actually something I'm learning about this now, that it's not loading the entire data set into your RAM. It's using memory map or memmap or whatever to just read sections of the file, sections of the data set, instead of like the entire data set. Though I wonder how that works with data sets that are like multiple directories, as in divided into multiple files and directories. Okay, verification, seeing the difference. To see that with format actually did something, don't look at the type, look at the output of an item. Yeah, that's true. That's true. Okay, data set, so and so, so and so. Yeah, we can do that. We can do that right now. Let's do, hold on. I can still print out this thing, right? So data underscore T 0 dot, okay, 0. What am I looking at? I'm looking at type here. hold on. So we're going to do 0 dot um, input underscore IDs. Zero input underscore IDs. We have a problem. Just a second. I think input IDs, there's a different way to access input IDs. Actually, is there going to be input IDs? I'm not sure. This is if I load a data set, isn't it? Yeah, so let's do this and then try to load this. No, we still have that issue. Actually, back up. Yeah, yeah. We still have that issue. Um, this is assuming that I've loaded a data set from datasets, as in from HF datasets, right? HF datasets would contain something like that. What about, okay, let's get rid of this. Yeah, this is still giving an error. Let's, yeah. All right, so what are we looking at here? Class dict. Well, I mean, we can see a difference, right? We can see a difference between this now, because in one case the data contains, hold on, data t, yeah. So both of them load a dict, but the data inside is a tensor. So that's kind of how we know that it's, you know, doing the conversion thing. All right, dude, hold on. We can change this. We don't need to do the varying shape anymore. Yeah, there it is. Okay, now hold on just a second. Um, Man, we streamed for what, 2.5 hours today? I think. I think so. I'm not sure. That's cool. Hell yeah. That's awesome. Just a second. Okay. Oh, there's someone doing something here. Let me see if it's possible to jump into there. What is this person doing? Okay, what is this person doing? Okay, you know what? We're gonna go to this person. Their name is, hold on, just a second. Okay. Okay, can't go to this stream. Just a second. Hold on. Uh, Hold on. Just a second. I'm just looking at some stuff. Okay, what's going on here? Never mind. It's a follower only chat. Alright, dude, we're gonna go to this person. I don't know what they're doing. Hopefully it's not a follower only chat. We're gonna go into, yeah, cool. Awesome. So we're gonna jump in there. Raid. Their name is Drawn Blood, and they're doing their makeup, I think. I'm not sure. Yeah. But yeah, that's gonna be it for today's stream. Um, it's been a pretty productive stream, dude. Oh, dude, we've done a bunch of research, learned a bunch of things, and I need to remember to make that social media post about um, installing and running LeRoBot and trying to load up stuff with LeRoBot dataset and stuff like that. I need to remember to make that post. Actually, I think right now after the stream I'll eat and then get to working on just that. And then I need to um, kind of refresh my knowledge on PyTorch data loader and actually learn about HF datasets as well. All right, cool. Yeah. That's going to be it for today's stream. Tan Dude, thanks for stopping by and chatting for a bit. And anyone else who might have been lurking in the chat, thanks for hanging out. Um, yeah, I hope you guys have a nice day, and I'll see you all next time. Peace.